As our first example of doing a true limiting reactant problem, we're going to look at a reaction of propane with oxygen, which is the burning of propane. Combustion process is what we'd call it. And you can see the balanced reaction here. Don't forget that there is a stoichiometric coefficient here. It's a 1, and we can use that. It's part of the stuff we will play with and use. So this problem differs in the picture view stuff we've seen before in that we're starting, instead of with the number of moles or the number of molecules, we actually have here something different. We have the mass. Because in essence, when we want to measure how many things we have, we want to count them, one of the easiest ways to do that is, if it's a pure substance, is to weigh it up, is to actually get the mass of the darn stuff by putting it on a scale. Once we get that scale, or once we get that mass, we can convert it into moles by using the periodic table. And that's what we're going to do. So in this process, we'll be using both the periodic table and the reaction to go from reactants towards products. So here's the idea. For each of the reactants that we have in a limiting reactant problem, we need to find out how much of a product we can make. Which one do we choose if there's more than one product? In this case, we've got two. We've got both carbon dioxide and water. Which one do we choose to talk about? Which one do we do the calculation for? Well, it's pretty simple. It's asking about water. So do the calculations about water and focus on water and ignore CO2 for now. If there's other questions about CO2 later, we would have to deal with those then. But for now, we can do our limiting reactant problem by focusing on just one product and one product only. So whenever we do one of these, we're going to be going from reactants to products, and that's how we're going to find our limiting reactant. That's our method. That's what we're doing in class. That's how we're doing it on the exam. That's how we're getting full credit. So keep that in mind. You must follow this technique to get credit. All right? Don't make up your own technique, and you're going to use this one. So if you don't understand this one from the videos and from what we do in class, you need to come see me or go to the tutor center and get help with this method. All right, so I've set up the first part of the problem, and we can see that it's already done. But really, I asked the question, how many moles of H2O, of water, can I get from my first reactant, which is C3H8 or propane? So I've got 52 grams of the stuff. I use the periodic table to find the number of moles of C3H8 because I can now cancel out the grams of C3H8. And now that I'm at moles of C3H8 right here, now that I'm at moles, I can use the balanced reaction, the 1:4 ratio, to get this next step right here. So this comes from the reaction. This comes from the periodic table. And when I'm done, I'm at my goal, which is the number of moles of H2O. All right, so I'm at my moles of H2O. That's how much I can make from this reactant. We might want to ask the question, though, how much we can make from the other reactants. So let me scroll down a little bit. Give me some room. We're asked that question. How many moles of H2O can I make from the oxygen that I have available? Well, I have available 97.7 grams. 97.7 grams of O2. If I look on the periodic table, I can find that there's 32.00 grams of O2 per mole of O2. And according to the balanced reaction, so where did this come from again? This is from the periodic table. And now my next thing is I need to find from I need to go from moles of O2 to moles of water. And I can see that for every 5 moles of oxygen, I get 4 moles of water. So for every 5 moles of O2, there's 4 moles of water formed. The moles cancel out. And now I can do the calculation again, which would be 97.7 divided by 32 divided by 5 times 4. And I end up with 2.4425 moles of water. So as I look at these two, I have a choice to make. Is it 2.4425 moles or 4.7155 moles? And as we saw before, it's the smaller number that we can actually make. So the limiting reactant here is O2, and we can make 2.44 moles of H2O.